and sit down.
So, when talking about 3D printing, there is a certain way of thinking from a modeling perspective that you need to apply. To keep it simple, a printer wants to read solid objects. When describing something that's solid, we often like to use very simple methods to understand what that might mean. So, an easy example, if you have a box, imagine that it's a solid brick of clay here that I'm focusing around. It has volume, surface area, and in architecture speaking, it's basically a mass. Then there's surfaces. They're different because they imply a shape, but they have no mass to them, no thickness. They are three-dimensional, but they don't have a thickness. So the box will print. The surfaces most likely will not. To start developing your objects to be printed, you have to evaluate which category your object falls under. Does it appear more like a mass and other solid shapes like spheres and whatever you can come up with? Or is it more like a series of pieces of paper that are shaped into a form? Or maybe like a fabric that is stretched around something or frozen in a specific shape? Depending on where in these categories you land varies what you'll have to do to get that object printable. Now, assuming your objects are hopefully a lot more complex than a box and a few simple sheets, some of you may have objects that start to look like this. Here's a more experimental version of solid versus surface. You can see a cluster of boxes I made real quick using a simple populate script in Grasshopper. And you can also see a tangled mess of surfaces that I thanked the Maelstrom command for, with a random sphere tossed in the middle just for fun. Once again, the solid object here will probably print fine. It's just a cluster of boxes, which has a lot of mass, has some kind of interesting holes here. And the second object is most likely to be a bit of a challenge. There's a lot of things that are free floating. There are very thin, very almost infinite edge kind of pieces going on here. So it's definitely going to be a bit of a challenge to get this thing to go off through the printer. What a lot of you are going to find is that your models may need to change, not just to fit the DVAA prompt, but also to actually succeed at being printed. Changes can be big, small, or cause a complete start from scratch, so it will rely on a good evaluation of the object in question based on the solid/surface categories I mentioned previously. If your objects are more mass-like, then you might be better off jumping ahead to the exporting process to test your models and see if it truly is print-ready. You can toss them in Cura, that'll be outlined in a later video, and see for yourself. I still encourage you to continue because I'm going to toss a few modeling tricks you can use to easily make either of these objects, depending on whatever state they're in, print ready. So something like this, as I've said, very massive. It's literally just a bunch of boxes instead of a single box. It's going to print very easily because there's a lot of overlapping volume here. If I were to toss a clipping plane in, just so you can kind of see a cross section real quick. You can tell that there's a bunch of overlapping boxes here that still all form some kind of volume. But if you look over on the surface, yes, the sphere has volume, so the sphere might come out fine. But all of these individual surfaces that are wrapping around like crazy are just the thickness of a line, and they don't really have anything to actually tell the printer to make. Because the printer is trying to read an object in a series of layers, it wants to read a series of sections through the object. The first step I like to take in evaluating an object is actually to use a clipping plane. Rhino 6 is best for this because it uses a fill reliably, and I've gone ahead and turned off edges so we're seeing just the inside. I changed the color to cyan to make it easier to see a cross section because that's really what we want to get out of this. On the left, you can tell there's a sort of mass to this object since it's all pochade on the inside. But on the other hand, once again, only the sphere is showing pochade, so the rest doesn't have any thickness to tell the printer what to draw. In a way, dragging a clipping plane like this up and down through a model is similar to how we will view the objects in Cura once setting up the print file. Since all 3D prints are built in a series of layers from the ground up, the printer needs something to draw for every layer that builds up an object. Thinking back once again to the shoe project, you want to imagine all models as a series of stacked layers. Making a paper-thin object like the one on the right out of stacked layers would be very difficult and highly inaccurate due to the thickness and curvature. So, ignoring the boxes for now, since it's mostly a good print file, more on that later, I'm going to focus on a few things to notice about the twisty mess that make it specifically trouble to print. So, one of the many things that 3D printers need is a surface to build off of. If you think about it, I'm gonna build a box here real quick just so we get a reference. The printer starts from a bed, which is basically just a flat surface on the bottom, and starts laying down filament as a means of building it up piece by piece, layer by layer, all the way till you get to the top of this object. Since printers can't fill in a space that can't read, so something that's super thin like this, as I've been saying, sometimes the easiest way to get an object to print is just to add thickness. To add thickness to something, there's really only one command that I like to rely on, and that's offset surface. So it's going to want you to select either surfaces or poly surfaces, which if you jump out of the command real quick, select something, see how it says one surface added to selection. Basically anything that you want to actually give thickness to. I honestly sometimes think of this command as add thickness instead of offset surface. Select all the objects that are going to be adding a thickness to them. Offset surface. And now it wants you to pick a direction to offset the surface towards. So if you kind of imagine it simply, I'm going to make a simple plane here just so we can understand what the tool is doing. Offset surface again. So you essentially imagine it kind of like it's offsetting a curve, like if you were drawing a plan. You're taking an actual surface and offsetting it by a certain distance. So something flat like this is basically just going to extrude. So if I do 2 feet, solid, yes, none of that stuff really matters for this purpose. Now all of a sudden it's a box instead of a plane. So for the sake of these objects, offset surface, it's going to be a little bit different because they aren't just planar, they have curvature and there are some tangents to it here too for when it's offsetting something. You can see these little arrows showing it's trying to pick a direction and which way to offset it. So just judging by this, it looks like it's going to take a little bit of time to process, but if you, I'm just going to go back to 1. Make sure it's set to solid. And there's a way to make it go in both directions, but for now I'm just going to do one-sided. Both sides just means it goes on the opposite side of the arrow as well as in line with the arrows. Hit enter. It'll load. And somehow we actually have fully solid thickened pieces. A couple things have changed about the model, so I'll just undo and redo to see the difference. You can see that now that we added a thickness, it actually made it look a lot bulkier. But now this object has a lot better of a chance of printing because if we show our clipping plane again, now we're seeing this nice solid fill going between the object, which means the printer will understand how to exactly build this surface. However, another problem we come to is that once we get to about this point, some of these objects are assumedly being printed out of thin air, and that is, quite frankly, not possible. So I've gone ahead and built in what are known as supports, The 3D printing software will most likely and usually generate these for you whenever you load a model into it. But for the sake of explaining, I've modeled a few in just to help understand why some things can't be printed the way they are. Since these objects are lifted from the build plate that we placed here previously, it means that they're going to need to be able to have some kind of structure for the printer to actually start laying down filament to print off of. If I go back to my clipping plane, you can see that if I drag it down, now that we have these white supports built in, that each of the pieces have something to rest off of. So if the printer was right here and then starts to build the actual model, they have their own kind of pedestal to sit upon so that it can start drawing the object and building it up from layers. Pieces over here where the curvature gets really sharp and it has kind of a very curved shape and it even sits off of the bed are also going to build supports under it. But that's all based on a lot of print settings, and it's something that needs to be considered with a print, especially like this, because inside of this kind of inner ring of this object is also probably going to be some support. So an object like this with a lot of stuff overhanging and kind of free flowing, it's going to need to build a lot of support, and the print's probably going to end up being mostly support rather than the actual printed file, which involves a lot of cleanup time after the process of printing itself. Objects like this are printable, but they do pose an additional challenge of cleaning all of the support up and actually getting a working final piece out. Using a simple set of pyramids like I have on the screen before me, you can actually determine how something might need to be supported. What the printer uses is a setting called an overhang, and it basically establishes the max degree that something can overhang. So if you think about the degree between this line and this line, and what angle that is, depending on how sharp or how narrow that is, depends on how the printer might actually be able to print it. So looking at this triangle on the left, or the pyramid on the left, you can tell that because the wider part is touching the base, which is what I've defined this green line as, it's not going to have any trouble printing because there's nothing overhanging. There's nothing that's draping down over top of this object that means it needs to make additional contact with the base. In the case of this other one, however, it will eventually need to, as it starts getting further and further out from this layer, start to build down and create support so that each of these individual layers has something to rest upon while it builds it. So realistically, whenever the print is done, you'll have the printed object as well as basically a wall of supports all the way around this pyramid that allow the object to hold itself up. If something was more straight like this, assuming that was a perfect triangle, it would probably be able to print itself because the layers don't have as much of an overhang. Consider it kind of like a slope. So really the printer could branch out and reach this little bit of a gap that is the difference between this layer and this layer. With a few extra examples, we can see that a lot of object overhangs will potentially need some support structure. Our box from the beginning of the video has a lot of overhangs in section, so that is something that may need to be considered. Flipping the direction of the section and looking at the second object, we can also see that these set of surfaces that I've thickened from the previous example show a considerable amount of overhang. That means they might need also some support to be built. In our third and fourth example, the ring, and another one that I've modeled real quick using a cage edit, you can see that a lot of these pieces, especially inside here, are going to need to have several sets of overhang built in order to create the entire piece. In some cases, like this, overhang will be built on top of the build plate, then printed, then overhang again, then more printing, then more overhang, and finally the rest of the print. Situations like these would mean that there's a lot of support structure to remove, which may make your object very difficult to come out nicely in the end. Depending on the object you make and how you choose to change it before it goes into the printer ultimately affects how it appears. The object on the end even shows some very steep overhangs by the end, which would most likely need supported by the printer. Depending on what you are going for in your design, offset surface may not be the answer for your object. There are hundreds of ways to consider closing off an object that affect its appearance. One that I like to do is extruding pieces of the object down or in another direction in order to make a surface and close it off. Since these have gone down below where my build plate is, I'll simply make a plane. Boolean split. And you can see that it creates somewhat of a different surface, dissimilar from the one that I showed previously. For objects like this that have somewhat of a vase-like or open mass shape, capping is another command that can instantly close planar openings in an object and make them a solid. Now the dialog box says one poly surface added to selection. If you don't like how the cap just works on planar only surfaces and gives it kind of a chopped off look, you can also consider doing something like a patch with these sets of curves. Doesn't always come out perfect or the way you want it to. But now the object has a completely different appearance than its original. The last thing to consider when assessing an object for its viability of 3D printing is to see whether or not the object has any holes. On the screen right now, you can see two of the same object that I did with the cage edit previously. One is just a complete poly surface, and the other I've turned into a mesh so that I could actually remove a few faces. You can see inside of the object and it's no longer solid. Again, we can test this with the clipping plane, because if the clipping plane goes to the object and it shows a fill, that means that the printer will most likely be able to understand the same thing about the object. If it goes through it and doesn't show a fill and just shows the inside like it's doing over here, that means that the object is not closed and the printer will have a tough time telling where the inside versus the outside is. There are many ways to fix this. One of the easiest is simply using the surface from 3 or 4 corner points tool and manually picking each corner to close it off with a few pieces like that. This isn't the quickest way, as most holes and objects aren't as convenient as simple square or triangle cutouts like the ones that I'm showing. Other methods are, again, using cap, but I don't think cap is going to work on this object because, one, it's a mesh, and two, these faces don't seem to be planar. Most holes in an object most likely won't be visible to you without inspection, so there are other tricks to identify and close these holes. Using the Show Edges command, a little window will pop up that allows you to analyze a different object and see what its edges are doing. Clicking All Edges in the dialog box lets all the edges in the object be visible. Naked edges and non-manifold edges let you select naked or non-manifold edges in order to view them and where they are. By using naked edges, we can see that this object has been chopped off at the edges, and that we can use something like patch or loft in order to close it off. Sometimes patches and lofts won't work. Depends on the curvature that you're given to work with in order to try and fix the object. Here it seems it tried too hard to fill in a shape. So you'll have to be discerning as to which solution you use. Here it might seem simple enough just to use 3 corner point surfaces and build a tessellated patchwork of the object until you can select all of the surfaces, hit join, and they become one piece again. Using the same tool and switching back to naked edges, we can see that nothing pops up red, so the object is fully closed. Even upon joining, you can see that it says 4 surfaces or poly surfaces joined into one closed poly surface. This pretty much covers the basics behind remodeling an object in order to make it go over to a 3D printer. This will at least give you some tools in order to understand how to convert something and what to look for that might be a problem for the 3D printer to read. This concludes the video, and I'll see you guys in part 2.